That's the cicadas. Oh, there's one. See him? There's all over the grass. I found a friend. He landed on me. We're gonna go straight because we want to get to the bend in Sawmill Creek. Yeah, right there.
See that floating bush?
These steps here are made of a local bedrock. Well, that's concrete where foot stood down, but this is bedrock. Obviously it's not in place, but it's a local carbonates. A lot of it's what they used to call Athens marble, which is just Dolo stone, sedimentary. It's not metamorphosed. And that's now called the Sugar Run Formation, mostly, but the Joliet Formation is also here. That's the main waterfall over there. Those rocks were placed. Waterfall, as you can see, most of it's man-made. You can see the concrete, you can see the stacked stones, but the bottom of it over here, the bottom, half, almost half, but more like a third, that's natural. That's a natural bedrock. And this waterfall was never this big. That was added to make it more tourist. But let's move on. These here are native stream deposits. The Sawmill Creek used to come further this way. We're actually going to go to this area up here. I want to talk to you guys about that because it used to be a pretty cool place, but since they modernized this, whatever the fuck that means, there's been it's not there anymore, but you can see there's mostly carbonate rocks and they're angular, I mean they're local, but then there's occasional glacial erratic like that that's more rounded. So this river was obviously cutting through glacial till to take things like this. There are no rocks like this within 1,000 miles of here. So, or I shouldn't say 1,000 miles. We're like 400. You can see this old cut bank of Sawmill, and this is a crappier exposure, but the contact's right about there of the Quaternary alluvium. This is pretty much glacial stuff. This is sort of a backup outcrop, if you will, but it's completely crappy and grown over. It used to be a really good one, which was right over here. I need to talk about that. The creek is right here. Now, all this stuff, this rock that I'm walking on, is from around here, but it's not native. It was placed here. I think 5 to 10 years ago is when they redid all this. Made it very appealing to families and stuff like that. But this used to be a dirt path. And behind me here, all grown over, and even erosion control over there with those rocks. But all this behind me here used to be an exposed cliff face of unconsolidated glacial deposits. It appears in an early Illinois State Geological Survey publication. I shouldn't say early, it was from the 70s. And I actually have come to this outcrop before and studied it in detail before they redid all this stuff. And it's actually in here, okay? It's in this book, page 34. Part 1 is just the background geology of Illinois, but this is the actual roadside part. It's this right here. We have a blue ball cap there. What we used to have exposed here is we used to have the basal gray till, or diamictin, of the Lamont Formation. Then above that, we had sands and gravels of the Henry Formation, a few feet, a meter or so, maybe a little more, I'd have to look it up. And above that, Wadsworth Formation. All are Wisconsin in age, and that all used to be exposed here until they redid this and basically covered up the outcrop to avoid slumping and stuff like that. So yeah, it's I know how I feel about it. I'm very upset that it is covered now. Now you got a little tree. You can see it hasn't been that long. None of these trees are more than 5 years old. So you can tell it hasn't been very long, and that's erosion control along with the boulders and the rocks. But this was a nice outcome. I mean, it was pretty stable. I mean, from the 70s to when I came here in 2010 or so, maybe a little earlier than that to start looking at that, you know, that's 30 years and it was still stable. So it could have stood another 30 more. But you know what, since they made it this touristy and stuff, people would have been climbing up and down it and probably would have messed it up and forced erosion on it anyway. So I don't know, maybe it is a good thing, but I still have records of it. I have better pictures of it too. So yeah, those I will put on the website for you guys. But we're gonna go down here because I actually have something from the next bend, but it hasn't been exposed in a while. Okay, down here, I actually have a piece of something from this location. I think I probably pulled it damn near 20 years ago. It's 2024, by the way. And I don't see any exposed here, but I am going to try to go out a little bit. The bedrock is exposed right here. Okay, we aren't that far from where that other cut bank was, where the good exposure of the glacial geology used to be. Maybe 200 feet, 60 meters, something like that. I don't know. But anyway, here in the past, this has been low enough to where the bedrock is exposed. The creek right here gets a little rapidy because the bedrock is right below here. You can kind of see it through a little bit. These rocks are generally right on the bedrock. And I have a rock from here from a long, long time ago, 20 years ago or so. And it had some interesting things on it. It had two main interesting things. And it was a great example of how you tell the difference between nicks and grooves due to glaciers and nicks and grooves due to stream pebbles. It has on it linear, parallel, maybe a couple millimeters deep, so 1/4 of an inch most, less than that usually, more like 1/8 of an inch, a couple millimeters. Grooves in it, those are glacial. They're parallel, all going in the same direction, and they're grooved into the rock. That means the glacier was carrying tools like these. Just use these as an example. On the bottom, as the ice came over, what it would do, and since the glacier is holding them, it would scratch the surface. And the glacier weighed a lot, so it could put a lot of more pressure down here than I can. So it would create those, and they wouldn't move. They would just form these parallel lines. We're pretending this is the bedrock. Now, what else it showed on there were a lot of marks like this. Kind of going randomly in every direction, just scratching the surface. Those would be from pebbles. How do I know that that isn't from some weird glacial thing and this isn't from pebbles or something? Well, I just explained to you why the straight parallel striations are glacial. And these are not, because as the stream moves, when it does get a little more powerful than this, it'll pick up stones and move them downstream. That'll nick the bedrock. And these were never deep, barely scratched the surface. And then the current would move them a little bit, spin them a little bit, so sometimes they would form little nicks. And that's actually how you get the beginning of potholes. Some of you who watch me know that up in the Upper Peninsula, we have potholes in like the Nunsuch and stuff like that. That's how they start. This isn't powerful enough, it never has been to create those, but it will do the nick. So those are the kind of things you got to be careful of in the field of doing field geology. Okay, you can't just assume glacial striations if you see nicks in rocks. It's not how it works. You got to look at the actual bedrock, and this is cool too, because the contact between the bedrock and the glacial is essentially the bottom of this Sawmill Creek. Now, I told you before at the last one you had the gray diamictin of the Lamont Formation till, and above that you had the Henry Formation. The Henry Formation is sand and gravel, and it's exposed here. So as the glaciers that deposited the Lamont Formation would wax and wane a little bit, you get these outwashes. You get these streams cut in, and they would just catastrophically dump stuff from the glacier. And that would form this. Like a pretty big boulder over there. There's no way, I don't know if you can see it, there's no way it's kind of brownish as opposed to the tannish, I hate that word, colors, but that's Henry, and it could dump bigger stuff like that, stuff this never could. And then later the glaciers would come re-advance over it. And the Wadsworth, what deposited the Wadsworth, Wadsworth is the youngest glacial till, Dimictan unit, in this area, that outside of Under Lake, Michigan. And this stuff, depending on where you are, with Still Valley, stuff like that, so it's real thick, but in general, it's a very thin till. So when the glaciers came and re-advanced over this stuff, and there's not always Henry between the Lamont and Wadsworth. Sometimes there's just a contact between the two, Paleosols, something like that. The ice couldn't have been that thick. And you'll hear people tell you when you're in school and stuff, oh, those ice sheets must have been miles thick, at least a mile, so like 1.6 kilometers. Or 3 miles thick. No, not out here. They could not have been. You don't see the deposits associated with that. The Wadsworth is so thin, I would be shocked if you came out here when the Wadsworth was being deposited and the ice was sitting here. Number one, it could have been as warm as it is today, the cicadas, and I'd be shocked if you saw more than 30, 40 feet of ice, so 10, 15 meters. I would be really shocked if the ice was thicker than that here. It's a misconception that these glaciers were just always really massive and thick. That's not. They flow easier when they're warmer, and they got further south. And as you go further per glacial cycle, you have set advance, retreat, pre-Illinoisan, and you have the Illinois, and then you have the Wisconsin, which is all this stuff. The glaciers didn't get as far with each consecutive re-advance. And actually, that's probably because the ice was colder in this last glacier cycle, so it didn't flow as easily. That's probably part of the reason. So we are technically still in an ice age. Whether or not the ice will ever come this far again, I don't know, but I can tell you we're waning from it, just from the patterns we see and stuff like that. So we're moving out of it now. Anyway, let's see if we can go down a little bit more. Okay, we've come a little bit further south of the last location. Maybe 20 meters or so, 60, 70 feet, somewhere around there. You can see we got a little more rapids here. But here we do have bedrock exposed at the surface. Right behind me, right here. This stuff is in place. Now, I don't have my Brunton with me and stuff. So how can I tell this is in place? Well, the fractures, these linear cracks, they're not faults, they're fractures, joints, stuff like that. They're pretty straight though. And don't let anyone ever tell you you can't get rocks that are shaped in like cubes and stuff, because you surely can. So we have these, and we know the trend of them. There's one set this way and another set this way. You can see it here and you can see it here. And this set goes this way. You measure those, and there is two structural trends of the bedrock in this area. Both of them follow that. I think one is north 20 east, and the other one's about 90 degrees to that. I forget off the top of my head. I will correct it on screen if that is not it. This is the bedrock. And you don't see glacial striations here because that top layer has been removed. It wasn't removed at the last spot, so I saw striations. This stuff has never seen glaciers touching it. It's seen the stream, Sawmill Creek, come through it. Now, you look at the rock, this is pretty much in place. I mean, it came right from here. I did not do this. You can see it's kind of this light yellowish brown. Tan is not appropriate color term to use, but I know people associate with that. You look at this is a bedding plane, this is a bedding plane. This is medium-ish bedded, thin to medium. And what you see here is you see the bedding planes are uneven. Now, the top one is, you can see, it's been pebble hacked. That's just what I call it. Pebbles hitting, but instead of forming those little notches and turning around, they actually break and crack. Hit and crack, hit and crack. Because this is a carbonate. It's not limestone, it's dolostone. Almost all the carbonates in this area have been dolotomized. So you have these little hack marks because carbonates are susceptible to water erosion, not only physically, but chemically. And same thing with the rain, because they react with very weak acids. Now, you see here, it's microcrystalline or micritic, kind of sugary, if you will. The texture of it's wet, so you can't really see it that good. But you see this bedding plane was on the bottom, and it too is not even. That's because these carbonates, this is an interreef formation that's currently called the Sugar Run Formation, the old Athens marble. A lot of the building stone in this area is from it. It's not very fossiliferous. It is even argillaceous, and what that means is it contains clastic fine clay particles in it. This is pretty pure dolostone though, although it is micritic. But this stuff is generally fossil poor, makes good building stones, and it breaks real easy along plains. So that's what this is. And right below that's a Joliet Formation. You can see over there, you see bedrock on the bottom of the creek. That is also carbonate. Now, this whole time you've heard me rambling about carbonates and limestone and dolostone. I have even given you the formation, but I have not told you the system that they belong to, the period. These are Silurian. This rock is Silurian. It's under, for those of you who know Thornton Quarry, which is east of here, 580, that's the formation above this. That's the Racine Formation, contains those massive reefs. That's very fossiliferous, but this isn't. This is right below that. And the Racine pretty much here, there's a couple isolated pockets of it, but it's mostly gone. There's another place further northwest of here where it is still in the cliff faces of the creek, but not here. So I think that's it. We're gonna move on, see what else we can see. Hey, this I just want to talk about real quick, other than all the cicada holes and the cicada shells. This, you can see this comes here, this stone structure. It's made of a local rock, probably from this very creek. The last place I just talked to is literally right behind us. But you see this is not natural. You can also see concrete on it. You look at the concrete, and you see the concrete has a lot of aggregate in it, and it's not very well concreted together. This is an old foundation of something. I have always seen this here. I don't know what it was for. You can even see down there, it had rebar in it, and part has fallen off. You see that, hon? Down there? You see here.
Oh, yeah, that's it.
You see it? Yeah, you can see there's old rebar in it. But it's not like 19th century. It has to be mid-th, 20th century. Mid-th. Is that a word? Mid-th? Mid-th, 20th century, right there. So there was some sort of structure here, and I don't know what that is, but I remember this. I've always seen it. It was a marker for me before they built all those shitty trails here and everything. So yeah, I really wish I knew what it was. And this is definitely from here. Although this stuff does not contain a lot of fossils like, you know, bodies of invertebrates, it does contain a lot of worm burrows. You see those in it. So I forgot to mention that. But yeah, these rocks are probably right from down there. Hello everybody. Now, I brought you to Waterfall Glen. I've shown you geology, and you've seen me with these guys. What are these? These are locusts, cicadas, and they're completely and utterly harmless. These are probably the females because they're in a group. Only the males make the obnoxious noise, surprise, so they can breed with these females, and that's what the holes are here. These are the 17-year ones that come up. I seem to remember them being bigger, but these guys are fine, completely harmless. They're dumb. They fly until they hit something. They don't bite. They don't carry anything. But I think they're pretty. Sarah doesn't like them, but I think they're awesome. Come on, bud. There you go. Oh, here's one. We got a visitor. They're pretty loud. Not as loud as me, obviously.